Your ears are sensitive to differences in pitch, but they are not very sensitive to differences in intensity. You are not capable of detecting the difference in sound intensity level of less than 1 decibel. By what factors does the sound intensity increase if the sound intensity level increases from 60 decibels to 61 decibels? So this is telling us that the sound intensity level beta is equal to 60 decibels, and that then it goes to 61 decibels. And the factor by which it increases is going to be equal to the second intensity divided by the first intensity, and that's what we're trying to find. And the equation for sound level intensity is beta is equal to 10 decibels times log of the intensity divided by the threshold intensity. Something that's important to note is that sound intensity and sound intensity level are different things. So these are for sound intensity and this is for sound intensity level. And we can see here that sound intensity level increases by 10 decibels each time that the actual intensity increases by a factor of 10. And we can also tell that because it's being, the sound intensity is being multiplied by 10. So remember not to confuse sound intensity with sound intensity level. With what we're given, we can write that the first sound intensity level is equal to 10 decibels times the logarithm of the first sound intensity divided by the threshold of hearing, and that the second sound intensity level is equal to 10 decibels times log of the second intensity divided by the threshold again. I erased the top more space, but this means that we can write that the second sound intensity level minus the first sound intensity level is equal to 10 decibels times the logarithm of the second sound intensity level divided by the initial threshold minus the 10 decibels times the logarithm of the first sound intensity level divided by the threshold. Remember to make note of properties of logarithms. So one of them tells us that log A minus log B is going to be equal to log of A divided by B. So this means that our equation is going to be equal to 10 decibels times log of I2 over I0 divided by I1 over I0. And that's going to be equal to 10 decibels times the logarithm of I2 over I0 times I0 over I1 because we flip them, and then I0s are going to cancel. So we're going to get that beta 2 minus beta 1 is equal to 10 decibels times the logarithm of I2 over I1, which is what we were looking for. Now we can begin plugging in some values to solve for I2 over I1. So 61 minus 60 is equal to 10 decibels times log of I2 over I1, which means that 1 is equal to 10 decibels times log of I2 over I1, and then we can divide both sides by 10. We're going to get that 1 decibel over 10 decibels is equal to log I2 over I1. Again, it's important to remember properties of logarithms. So log base answer is equal to exponent, and base to the exponent is equal to answer. That's how I remember it. Here base is 10, so you can write that our base 10 to the 1 over 10 is equal to I2 over I1. So the factor by which the sound intensity increases, I2 over I1, is equal to 1.26 watts per meter squared. And that's the answer.